All right, if I remember correctly, we were in the middle of commands talking about them. So I'm going to do a quick refresh on this just to make sure so if you have any questions, speak up. ls gives you the listing. Under DOS, it was dir. But here it's ls-a will display anything hidden, aka files that start with a dot are usually considered hidden files inside Linux. -big A will basically display everything except for first dot and dot dot. Dot points back to the same directory, dot dot points to the parent directory. L is for long, S will just do file size, and H makes it a more human readable format. If you remember, it would add the kilobytes, megabytes, and gigabytes, or terabytes if you actually have that running around. CD, how you change a directory. Dot dot to go up a level, CD slash to go back to the root, and CD just changes it to your home directory. mkdir, that's how you actually create a directory. You can make a directory, and you can actually make a directory inside of a directory if you use slash. Very important for your Windows users. Linux uses /, not the backslash. Don't be doing backslashes. It can only cause sadness. And rmdir is to remove a directory. All right, we didn't care about cat. All right, cp is for copying. Copy a file. You can make it interactive with -i, make it verbose with V. And then R, what did R do? Make sure y'all are paying attention because this is important.
The big R's.
Yeah, recursive. What does that mean? Yeah, it goes through into the directory and goes down all the levels and copies everything as well. All right. RM will remove. You can remove a file. If you do a star, it removes everything in your current directory. -F forces a remove, so if there was a read-only file, it wouldn't ask you, it would just do it. Recursive removes all the files, including subdirectories, and -V will tell you what it's removing as it's doing it.
So you can watch your entire system go down?
Sure.
So it deletes everything?
Mm-hmm. But it does slow it down significantly because you have to print. All right, I think that's where we left off. Were there any questions about those commands, the real basic ones? Okay. So any command that accepts a file due to the way bash works, because y'all are probably using the shell bash, but due to how bash works, any command that accepts a file as a parameter assumes that file is in the present current working directory. So when you do pwd, let me go over here. We'll go over to the class code. And what were we? We're under quick. So it assumes it's in the current directory. I did an ls at file2, file1. So if I were to do cat file.txt, it just assumes it's in that current directory. For example, if I was trying to get something from etsy, what do we have in here? Add user.conf. I would have to put in the slash. I can't just do cat add user.conf because add user.conf does not actually exist right here. I would have to do etsy add user.conf. All right, great. Absolute paths start with the slash, so that's what I was doing here with Etsy. Whoa. Okay, good. My screen blacked out for a moment. This is what I was doing with Etsy. I had to start with slash, which is an absolute path because it starts from the very root, and then you specify exactly which directories you go through in order to get to the file. So that's an absolute path because it's absolutely right there. Relative paths are the other type, and they never start with slash. They're how to get to the file from where your current directory resides. For example, I'm under the quick directory, pwd, home, plus, csu, etc., quick. If I do an ls-s/, that's a relative. It tells me what's up a level. Notice that there's this grep directory, which we're going to talk about soon. So if I do an ls on /grep, I have a grep file. So if I wanted to cat it, cat./grep file, and that's how I would get to that file from my current directory using relative addressing. If I wanted to use absolute addressing, I would do cat/home plus csu, courses, csci 315, class code, grep file. And then it would do the same thing. All right. You see how there are two different ways to get to the same file. All right. So move moves a file or renames it. It actually just moves the file, but when you move a file, you are technically renaming it as well. So you can always move a file up a directory or move a file from one location name to another location name. So there's no rename here because move is rename. So we're inside quick, we can do move file dot, now we'll do file2. File2.txt to dot slash. Notice that pushes it up a directory because it's not here anymore. But if I go up a directory, there's file2. I can do move file2. Where was I in quick? I can call it file3.txt. So I'm moving it into the quick directory and renaming it to file3. Probably should expand this so it's a little easier to see. There we go. Now if I go inside of quick, there it is, and now it's called file3. All right, we're good? Good? Good, all right. PWD prints the current working directory. File displays the file name, gives you some information. This is actually a fairly useful tool. You go file3.txt. It's a file ASCII. Well, that's probably obvious because it has a .txt file. But in Linux, Linux actually does not care about extensions. Watch. There. Don't have the extension. It's still an ASCII file. If I were to open it, it still works just like an ASCII file. The information of a file is not tied to its extension at all. The extension is just part of its file name, actually. The file name under Linux is blah, 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 and then you added a .txt at the end. So it's not, the extensions are meaningless, but can be helpful. All right, head shows the first few lines of a file. Tail is going to do the last few lines, and WC is going to do word count. Okay. Let's go back to that grep file, because we'll be messing with that a little today. So we're going to do head-in, well, let me cat it first. Grep file has, looks like 5 lines. If I wanted to just print the first 2 lines, head-in2 grep file, so those are the last 2. If I wanted to print the last 2 lines, I could use tail. And if I wanted to do a word count, WC, grep file, 5 lines, looks like 34 words, 184 characters.
Does that include space or not?
I don't recall. Let's do a man on WC. When you don't remember, print new line, word, and byte count. So, oh, it's not only is it space, it's return. Oh, of each file. There we go. And a total line if more than one file is specified. All right, what was this? When you're trying to remember how something works, type in man, which stands for manual, WC, aka the command, and it'll go and print it up. You can use your arrows to go up and down. If you want to search it, you hit / and type in what you're looking for, like read, and it'll jump you down to it. If you want to look for the next one, just keep hitting lowercase n or big N to go back. And then Q is what you use to quit. Remember, to get out of the manual pages, you use the letter Q for quit. And these exist for most commands you have out there. See, I can do man on CP. Here's the explanation as well. Okay. Find. If you wish to find a file, that is not a good way to use find. But if you're trying to find that grep file, whoops, you can do find-name grep file here. Paths must file find is the only one that does this in reverse. and then you first specify where you want to look. I usually just use star. And then dash name the file you're looking for, and it can tell you where it is.
Is that from your current directory?
From my current directory, correct. So if I were to cat that, there it is. Oh yeah, copy and paste. By the way, if you highlight something, just do a middle click and it'll paste it for you.
Middle click.
Your mouse has a middle click button? No? You don't have middle click?
Where are you doing mouse?
Mouse right now.
Okay, well if you don't have middle click, sometimes you do both mouse clicks at the same time and it'll register as a middle click.
You can
Unless you're using a Mac, then I'm sorry.
It works if you do Control C and then right click where you want to copy.
Okay, so you can do all that as well. That's
It's
way
not
too,
as easy.
way too complicated.
It's way harder.
Way harder. Lame.
If you only have them like this, it works.
Okay, we're going to go into grep, and ln is actually not important for this class. You'll learn about ln and operating system. Okay. We do have to go over at least a little bit about how processes work in this course for since you're using the command line. Every process in Linux has 3 standard input and output devices. You have standard in, that's std in. That is your, when you're on your terminal, that is your keyboard input. std out, that's standard out, is your standard monitor output. It's what's displayed on your screen. Now, standard error is actually an error output device. In general, standard error also goes out to your screen, but they are 2 completely separate streams. So, you have your process, your program, maybe you wrote it, or maybe it's word count. Standard in comes out, comes out, and then it either prints the standard error or standard out. All right. Now we have boxes and arrows. What's the first thing we do? So, hold on.
I've seen these slides, so.
What do? You got boxes and arrows. What do we do? Mess around with it. Well, we have a process. We have something coming in, and then stuff comes out. If we create another process, what do we do? That's the program. That's the program. We got boxes. We got boxes and arrows. What do we do, guys? Whenever you have boxes and arrows as a kid, what do you do? Run away?
Draw in new shapes.
Draw new shapes. All right. Well. Okay. Hold on. This is computer science. Unless you're doing a crazy network diagram, we just use boxes and arrows because anything else is way too complicated. Sometimes you have to take a course on box drawing. Just to get this. You're not there. You're not ready for that. All right, guys. We have this. What's the first thing any child would want to do? I guess I would want to do. Hook them up, right? You have an LS. Let's take it standard out and hook it up to more, another program, and then it'll do something with it. So you can start chaining processes so that one process, LS, talks to another process called more, which may talk to another process, to another, et cetera, as long as you need to chain it. And this can continue on. The example here, the way you do this is with the pipe symbol. That is, you hold down the shift button, and it's that key above return, at least on my keyboard. I don't know if there are other keyboards that do it differently. So let's go ahead and let's take a quick look at what this looks like. If I do ls-al, that's just that stuff. But if I do it on Etsy, it's way more than what fits on my screen. So if I add pipe more, it starts at the top. And what more allows you to do is you look at everything one page at a time. So when you're done with this page, looking through it, you can hit the space bar and continue on until you finally come to the very end. Now, as you can probably tell, that's somewhat limiting, right? One page at a time. So you probably want to have a program that is a little better. Maybe you can scroll up and down, maybe you can search. If this program is called more, what do you think the other program is called?
Less.
Right. No, it's called less. Tyler's got this, yeah. So you pipe it to less, you can scroll up or down. If you wanted to search for something, like let's see, hosts is at the bottom. I can do hosts. There it is. Use N to cycle through it. I can use page up and page down to go through it. So what does this tell you? Less is more. You got it. So your two common choices for displaying less or more, more or less. So we'll continue on. Come on, guys. This is how it works. It's called Bash, all right? Your shell is called Bash. They had fun with this. I haven't told you how you get rid of a process, but if your program is not running correctly, the command to get rid of it is literally kill. You just type kill space the process, enter it, and it'll try and do it. All right. Anyways, IO redirects. This is if you want to take some output and put it to a file. For example, we have ls-/etc, prints it all to a screen, but let's say for the sake of argument, let me go up back to quick. I do ls-al/etc, and I'll pump it to out file. It says OK, notice it didn't print anything. That's because it actually took all those contents and put it into an ASCII file called out file. So if I were to open up at file, and I'll use gvim just to really show this, that file now has the contents of everything that was printed out, and you can use a text editor or whatever you want, email it to your friend if you felt so inclined from there. So single will create a new file, it will overwrite it. Double arrows tells it to append to it, so it's not going to overwrite it. So for example, if I were to do, what do we have? Do we have serve here? So, that's not a very big one. How about var? Okay, good, we have some things in var. And I put it to out file, and then I open up out file. Notice that out file was overwritten with the new contents. On the other hand, if I go back to my previous command, by the way, to go back to previous commands, you just use that up arrow and it'll start going up. And I put in a double greater than sign. When I open up out file, notice I have my previous stuff written, and then it appended everything else. So that's how you can save all your previous work, so to speak, inside of a file. If you're having problems, it won't let you do it. Just put in the bang before the greater than sign, and it will force it. Okay, so we already talked about less. We talked about more. Cat concatenates. So you can actually concatenate more than one file if you felt so inclined. You can do cat file.txt and file3. Notice that those were the outputs or the contents of both of them. Let me go back to maybe a better example with quick2. So I can do cat file2 and file.txt. Oh, that wasn't a good example either. Let me go mess around with file2. Let me at least make it separate lines. There we go. Notice it printed file2 first and then the other file. It just happens in the order that you put it in. There it's in the opposite order. And then, of course, if you felt so inclined, you could do file3.txt. And now it's both of them. Okay. Talked about TAC. Printing, we're not going to be printing in this class, so we don't have to talk about that. Don't care. Password is generally how you change your password. If you ever need to, just type in passwd. Yeah, it would have been too difficult to add that O and R in there. That's right out.
Too much.
Too much. Man's for your manual pages. Info is similar to man. They'll give you, some programs use info instead of man. And usually when you're trying to run a program and you don't know what to do, a lot of programs will have a -help. So for example, if I try to do GCC, it says no input files, GCC-help. Oh, it still doesn't tell me anything. Oh, --help. It might give me some more information that might be helpful. But this is kind of like that help menu in GUIs, if you've ever had to deal with that. Just going to leave it at that. Okay. Any questions about commands? So, a little bit about piping we've talked about. You're probably going to have to get a little bit more used to piping before you become masters of it. But that's okay. Any questions about these commands? I'm going to pause and start a new video soon.
Nope. All right.